In this video, we are going to learn how to solve these physics repeated questions under resistance in series and parallel. We are going to practice with 9 repeated questions for this subtopic under current electricity. Okay, so let's get started. The first question here says, find the effective resistance in the above diagram. Alright, so for this particular questions, the resistors, all of them are connected in series. So basically, the effective resistance will be sum everything there. It will be 4 plus 4 plus 4 plus 4 plus 4 plus 4. So this is plus, guys. So we have 4 into 6 places. So this will give you 6 times 4, which will give you what? 24 ohms. That will be the answer to this question. Alright, so let's wipe this now and go to the next repeated question. Alright, let's go to the next repeated question, which is this one. It says, in the diagram above, what would happen to the current if another resistor R2 is connected in parallel to R1? So basically, we have option A to be to decrease if R2 is greater than R1. It will increase because the equivalent resistance will increase. C, it will decrease if R2 is less than R1. D, it will increase because the effective resistance will decrease. Okay, so the correct option to this question is option D, which is it will increase because the effective resistance will decrease. So that will be the correct answer to this question. Take note of this particular question, guys. Alright, so let's go to the next repeated question, which is this one. It says, 4 resistors of resistance this value are connected in parallel. Calculate the value of the combined resistance. So it's talking about parallel connection now. So for parallel connection, this is a formula 1 over R equals, we have the first resistor to be 3 plus second one is 8, the third one is 12, and the fourth one is 4. So the LCM is 24. 3 into 24, we have 8. 8 into 24, we have 3 plus 12 into 24, we have 2. 4 into 24, we have 6. Okay, so 1 over R equals this. So when you sum what you have at the numerator, you are going to have 19. So we have 1 over R equals 19 over 24 cross multiply. So we have 24 equals 19 R. By both sides by 19. So this you can see self, our R would be, let's punch this on a calculator. So we have 24 divide 19. So the answer is what? 1.26. So correct option is option B. It's as simple as this. Let's wipe this now, solve the next repeated question. Okay, so the next repeated question will be this question. It says 4 resistors connected in parallel have a potential difference of 12 volts applied across them. What is the total current in the circuit? Alright, so for this particular question, we have resistors connected in parallel. 3 resistors connected in parallel. So let's get the sum of the effective resistors. So it's 1 over R equals 1 over 4 plus 1 over 4 plus 1 over 4. So we have the LCM to be 4. So 4 into 4 are 1 plus 1 plus 1. This will give you 3 over 4. So we have 1 over R equals 3 over 4. Cross multiply, we have 4 equals 3R divided both sides by 3. So your R is what? 4 over 3. Remember Ohm's law, V equals IR. So in this question, we have the volt to be 16 because we are looking for the current unknown. The resistance now is 4 over 3. Alright, so to make I the usual formula, divide both sides by 4 over 3. Divide 4 over 3. So this you can see itself. Our I will be, now under we can express what we have here. This is same thing as 16 divide 4/3. Alright, so when you cross multiply, you invert what you have here. This is 16 times 3/4. So let's break this down with a calculator we have here. We have 16 times 3 divide 4. So we have the output about 12 ampere. So the correct option is option B. That's for this question. Let's wipe this now, solve the next repeated question. So the next repeated question will be this question. It says a circuit has a resistance of 200 ohm. The resistance of the circuit can be reduced to 120 ohm when option A 150 ohm resistor is connected to it in parallel. Option B, an 80 ohm resistor is connected to it in series. Option C, a 240 ohm resistor is connected to it in series. Option D, a 200 ohm resistor is connected to it in parallel. So the correct option this question will be option D. Let me show you guys how it will be option D. Remember, we're talking about a 200 ohm resistor is connected to it in parallel. So since this parallel connection is going to be 1 over 200, we are experimenting over 1 over 300. So LCM is what? 600. 200 into 600 we have 3 plus 300 into 600 we have 2. So that we are left with 5 over 600. Alright, remember 1 over r equals this. So when you cross multiply, you're going to have 600. This is 0, guys. We have 600 equals 5 r. Divide both sides by 5. Alright, so 600 divided by 5, you're going to have 120 ohms. So that will be the correct expression for this. So this is valid option D. When 200 ohm resistor is connected to parallel with this resistor we have here 200 ohm, you're going to have it reduced to 120 ohm. So it's correct. Let's wipe this now, solve the next repeated question. So guys, the next repeated question will be this one. It says in the circuit diagram above, the key case is initially open. When the key is closed, the reading on the ammeter where A remains unaffected, B decreases to 0 because of short circuit, C decreases to 1/3 of its initial value, D increases to thrice its initial value. Now guys, before I say something about this question, if you are new to our channel, ensure that you are subscribed to this channel for more of my videos. Really appreciate this, guys. Okay, so for this particular question, the correct option will be option D, which is increases to thrice its initial value. When you solve this we are going to arrive at, it will increase thrice its initial value. Alright, so just take note of this particular question. The correct option is option D. Alright, so let's go to the next repeated question. Alright, so the next repeated question will be this question. It says find the effective resistance of the above combination. Alright, so for this particular question, the resistors here are connected in parallel. So from parallel connection, the formula is we have 1 over r. The sum of the effective resistance will be, the first resistor there is 3 from these values we have here. Alright, plus second one there is 6, the third one there is 9, and the fourth one there is 1. So the LCM here will be 18. 3 into 18, we have it to be 6. Alright, so 6 times 1 is 6, plus 6 into 18, we have it to be 3. 9 to 18 is 2, 1 to 18 is 18. So we have 1 over r equals, when you sum what you have here at the numerator, you're going to have 29 over 18. So when you cross multiply, you're going to have 18 equals 29 r. Divide both sides by 29. You can see self. So our r will be 18 divided by 29. So we have output to be what? 0.62 ohms. So the correct option is option A. It's as simple as this. So lastly, before I call it a class, let's write this. So the last repeated question will be this question. It says a lamp is connected across a battery. A piece of low conductivity wire is now connected in series with it. The lamp will Option A, quickly burn out. Option B, glow brighter. Option C, glow dimmer. Option D, remain unaffected. So correct option here is option C, it will glow dimmer. Alright, so this basically can do problems involving resistors in series and in parallel. For your business, hope you learned something interesting from the video. Let's call the video here, guys. If you are new to our channel once more, ensure that you are subscribed to this channel now by hitting the subscribe button for more of our videos. Also like, share and comment on this video. Where I feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave a question in the comment section below and I'll be sure to give you a response. Also ensure that you are part of our channel membership by clicking on the join button to become part of the community there. In our channel membership, we share special information that helps to simplify academic work for members of the community. So join us now, I'm glad you did. Alright, now click on the screen above and I will see you in the next video. Thanks for watching.